All right, so we are going to look at another systems problem, another system of linear equations, and we're going to use elimination again because, Miss Holt likes elimination, and I think it's a pretty good method. And this is our problem. We have 4x plus 2y equals 3. We have 5x plus 3y equals 4. Now, instantly, I'm like, oh, look at the structure, like 4x, 5x, they're lined up, 2y, 3y, yes! And then we have equals, and we have our numbers on the other side. And I'm thinking, oh, this is perfect for elimination. But 4x and 5x aren't going to eliminate. 2y and 3y aren't going to eliminate. So I'm like, all right, can I change the 4 into a 5? That sounds hard. Can I change the 2 into a 3? I don't know, that sounds hard too. I'm not seeing this, Ms. Holt. You got any suggestions?
Besides using decimals, I probably could see if I have any common multiples with 3 and 2 if I was to do this. I work better with 3s and 2 multiples than probably 4s and 5s, so I'm thinking 2, 4, 6.
Oh, you can make them both into 6.
I can make them both into 6.
I see it.
But that does mean that we are going to have to multiply both equations by a number.
You take the top one, I'll take the bottom one.
Awesome.
All right, sweet.
Because I want this top one to be 6, that means I'm going to have to times everything by a 3 over here.
And I want to make this bottom one, I want to make that 3y into a 6y. So I'm going to have to multiply this entire equation by 2, because that's going to make that 3 into a 6. So I'm going to get 10x plus 6y equals 8.
And remember, our whole purpose was to eliminate. So we see that they're all positives, which means if I subtract these two, I can eliminate one of my variables.
Which way to subtract, though? I mean, do we want to take the green minus the blue, or do we want to take the blue minus the green?
Definitely looking like this 12 is bigger than that 10.
Yeah.
So what doesn't Mr. Painter move his equation on over here?
Oh, I got to move mine to your side? I see
Yeah.
how it is.
You always make things a little bit more difficult.
Oh, I'm trying to be a gentleman. I'm helping out the ladies.
And look at this nice thing we're noticing. We have 12x minus 10x, we're getting 2x. 6y minus 6y, awesome, those are eliminated. We no longer have a y because we need to put 0y to be efficient with our time. And 9 minus 8, we get 1. Now this is a problem we can solve.
Yeah, I mean, we do have to solve this. So the question just becomes like, we want to get rid of this multiply by 2. So I'm thinking, hey, we divide by 2. And this brings up a question. Do we want to use a fraction? We want to use a decimal. I mean, I can say that x, this is going to eliminate. We can say x is 1/2. We can say x is 0.5. I don't know. What do you think, Ms. Holt?
Well, if I'm looking at this, and I'm actually looking ahead as well, and I do know and remember that I have to put this x back into one of these equations that I use. But remember, I could put it into this one, I could put it into this one, I even could put it into these new ones that we created over here.
Let's not get too crazy.
Looking at this, really, do I want to take half of 5, or would it make more sense to take half of 4? So whether I decide to use 0.5 or half, it's not going to really play a factor when I plug it back into this equation.
All right, so, let's stretch your minds a little bit. Let's say 1/2.
So remember, this is where these two graphs, where these two linear equations meet. We need a y-coordinate though. Here's our x-coordinate. Let's take this top one, and instead of putting x, we now know our x value is 1/2. We still have this 2y equals 3. Mr. Painter needs to work on some multiplication of fractions, so go ahead, Mr. Painter.
4 times 1/2. Well, I know what the answer is, at least I hope I do. So 4 halves, that's 4 halves of a pizza is 2. But heck, I could always look at 4 as thing 4 over 1 if I want the common structure, so I can just multiply straight across. And I get 4 over 2, which 4 divided by 2, that's 2. So we really get 2 plus 2y. Thank you, school, for that bell. That was beautiful. I like that. Isn't that a nice note? Anyway, so does that mean we're almost done?
It looks like we're almost done. I see this in my head. I'm looking ahead of things. Look at how good the solution is going to be. I know that I'm trying to get my y isolated. I also know that I have to get rid of this plus 2 over here in order to start that. I am going to subtract 2 and see that now I have 2y is equal to 1, and I'm smiling even bigger. Why, Mr. Painter?
Because that looks just like that. So, we already know what the answer is. Y's gotta be 1/2. We could divide by 2 and divide by 2. This means for us, x is 1/2, y is 1/2. So these two lines, these two linear equations, they actually have the same solution of 1/2, 1/2. That's their intersection point.
Which is awesome. And we know this is where they intersect. And if you're wondering if all this math makes sense, remember, we can plug this into any equation we want to check. Now, I did use this one, which remember was equivalent to this one. This was Mr. Painter's over here. I'm seeing even numbers here. I can think, oh, I could just plug it into this one. 1/2 of 10 is 5. 1/2 of 6 is 3. Does 5 plus 3 equal 8? Yes, it does. That makes us happy.
I love that smiley face. It just doesn't get old. Hey, speaking of not getting old, by the way, this problem doesn't get old. Let's look at some other ways to solve it really quick. I said I couldn't make the 2 into a 3. That's a lie. Ms. Holt, we're going to have a little game. So I could make that 2 into a 3 by multiplying this top equation by 1.5. So that I could have eliminated it that way. Can you come up with another possibility?